Now we're going to look at how we can compute a z-test p-value using Excel. And I'm just going to say in advance, we have to be a little bit subtle, we have to be a little bit clever about what we're doing here, because the z-test function in Excel isn't designed for this type of approach. Anyway, here we are working from a data set where we have an average of 809 from 37 in the sample. And what we need to understand is that the function we're going to use here is designed for working with that entire data set, not the statistics we've been given. So we kind of have to trick it. And the best way that I have to do this is we put in that mean 809, and then I'm going to make a copy of that. It's an odd thing to do, but once I make the copy, I'm then going to take 36 cells up in here, and I'm going to make 36 copies of that mean. It's a very odd approach just looking at it, but what I'm doing here is I'm making a sample that I know has an average of 809, and I don't have to be at all careful about what goes on with the standard deviations because I don't care about the standard deviation of the sample. I already know what sigma is, and knowing what sigma is really does most of the work there. So I just make that whole thing, and you could probably rig something up with a random number generation to give you a mean of 809, but the easiest way to do it, in my opinion, is just start with that value and stick to it, as it were. So once you have that data set, we're going to go over here and we're going to put in equals 1 minus z.test, and the reason why we're doing 1 minus is because this is designed for, I'll say right now, the wrong kind of tail, but I'll explain what that means a little bit more in a second. We're going to put in there for our first entry, our data set here, our fake data set of 809s. And you can make that a single row, a single column, whatever you want. I just made a clump that's got a weird sort of thumbs up shape so I could make it fit easily on this page. But you put that data set in there, then you're going to put in the mean you're comparing it to. That's 835 in this case. And the standard deviation here of 53. Check that, and you get the z-value that we were supposed to have here. If you got that from the table or the calculator, of about 0.0014, where, for one, the reason why we did that complement thing is because the z-test function as it is, so I'll run through the test without making that complement just so you can see it, is really designed for dealing with cases where we want a right tail, that is, cases of greater than, as it gives the probability beyond by default. So if we need a left tail, we have to use a complement, and if we need two tails, we have to multiply the whole thing by 2. But it just takes a little bit of subtlety, a little bit of carefulness with what we're looking for to get the appropriate value there. And again, this isn't really what the thing's meant to run on, but we are able to make it happen.